So what is traveling salesman problem? So traveling salesman problem is a method of assignment, and in column scanning, in first column no zeros, in third column I have 1 0, put a horizontal line. So you have to do the row scanning and column scanning until we reach the optimality condition. So this diagonal matrix value is always infinite value in traveling salesman problem. So in second row I have 1 0, I'll put a square box around that 0 and put a vertical line. Hello everyone, welcome back to my new session. I am Shweta, Computer Science faculty. So in my last session I have discussed about traveling salesman problem. So it is very easiest concept, right? So I have discussed one problem and introduction. So today I will discuss some important problems on traveling salesman method. So first problem in traveling salesman. So what is traveling salesman problem? So traveling salesman problem is a method of assignment problem. So we have to apply some conditions for traveling salesman problem. So what are the conditions we have to apply for traveling salesman problem? So salesman has to visit each and every city exactly once, and has to return back to the same point. From where he has started, he has to return back to the same point. So these are the conditions we have to apply while doing the problems. So traveling salesman problem is a method of assignment problem and some conditions we have to apply. So this is your first problem. So here in diagonal matrix, they will give the 0 value or infinity value. So this diagonal matrix value is always infinite value in traveling salesman problem. So first step is row reduction and column reduction. In first row, the least value is 25. Diagonal matrix value is same. 25 minus 25, 75 minus 25, 45 minus 25, it is 20. In second row, the least value is 25, 10, 125 and 0. In the third row, the least value is 15. So 20, 25 and 0. Last row, least value is 65, 10, 65 and 0. And column reduction, by using this row reduction, we can find the column reduction. In first column, least value is 0. In second column also least value is 0. Third column, least value is 0. Again, you will get the same value. In fourth column, least value is 0 only. You get the same value. By using this column reduction, in next step, we can find the row scanning and column scanning. So, we have to assign the 0 to the right operator. In row scanning, first we have to check the 0. If you get 1 0, you can put a square box around that 0. If it is 2 or more than 2 0, you can skip that row. So, in second row, I have 1 0. I'll put a square box around that 0 and put a vertical line. And in third row, I don't have any other 0. In fourth row, I have 1 0, put a box and vertical line. So row scanning has completed. Now it is column scanning. In first column, all the values are deleted. In second column, I have 1 0 and put a horizontal line. In third column, there is no 0. So now row scanning and column scanning has finished. So now you have to check whether it is satisfying the optimality condition or not. So now I have assigned only 3 zeros. So it is not satisfying the optimality condition. So now you can check the deleted cell values and undeleted cell values. Among these undeleted cell values, the least value is 10. Pick this 10 as the least value and subtract with the other value. So diagonal matrix value is same. It is infinity or 0. And the undeleted cell values are 75, 25, 10 and 15. So 10 minus 10, it is 0. 15 minus 10, 5. 25 minus 10, 15. 75 minus 10, 65. I have written undeleted cell values. And the remaining values are same except this common for both horizontal and vertical line. So add this 10 to this common point. 20 plus 10, 30. And the remaining values are same. 20, 0 and it is 0. And now again I will find the row scanning and column scanning. So in first row I have 2 zeros. So now it is not satisfying the optimality condition. So again I will find row scanning and column scanning. Until we reach the optimality condition, we can go for row scanning and column scanning. So in first row I have 2 0, just skip that row, and in second row I have 1 0 and put a vertical line. In third row no zeros, in fourth row I have 2 zeros. And now next is column scanning. In first column 1 0 is there, put a horizontal line, and in second column 1 0, put a horizontal line. And in third column I don't have any other zero. So now again you can go for the least value. Among this undeleted cell values, you can pick a least value. So least value is 10. So 10 is the least value. Subtract with the other value. Infinity values are same. So 10 minus 10, 20 minus 10, 0, 0, 5. And 15 minus 10, 0. 65 minus 10, it is 55. And 0, except this common point for both vertical and horizontal line. So 30 plus 1, it is 40, 0 and 0. Now again you can do the row scanning and column scanning. In first row I have 2 zeros, I will skip this. In second row I have 2 0. In third row I have 1 0 and put a vertical line. And in fourth row I have 2 zeros. Next is column scanning. In first column I have 2 0, second column I have 2 0, in third column I have 1 0 and put a horizontal line. So now, again I am doing this row scanning until we reach the optimality. So in first row all the cell values are deleted. In second row I have 1 0, 1 0 is cancelled. You can put a vertical line. And in third row I have marked, and in fourth row I have 1 more 0. Now you can verify whether it is satisfying the optimality condition or not. 1, 2, 3, 4. So 4 is equal to 4. So it is satisfying the optimality condition. So now we got the optimal solution. Next step is we have to find whether the salesman has visited each and every place exactly once or not. He has traveled from A to C and C to D and C to B. So he has traveled from A to C and C to D and D to B and B to A. So he has traveled each and every city exactly once, and again he returned back to the same starting point. So now we got the optimality condition. So what is the assignment? So A to C means the original value is 75. And C to D. C to D is 15 and D to B. D to B is 65. 65 plus B to A. B to A is 35. And the total cost is 190 minutes. So this is your traveling salesman problem. So you have to do the row scanning and column scanning until we reach the optimality condition. So traveling salesman problem is a method of assignment problem, but we have to apply some basic conditions. Salesman has to visit each and every cities exactly once, and again he returns back to the same point. That is called as traveling salesman problem. And the next problem, here I have 5 columns and 5 rows. So all the diagonal matrix values are infinity or zeros. So first we have to check the row reduction and column reduction. Please verify the row reduction and column reduction. So in first row, the least value is 4. So 7 minus 4 is 3, 6 minus 4, 8 minus 4 and 4 minus 4. In second row, the least value is 5, 7 minus 5, 8 minus 5, 5 minus 5, 6 minus 5. And in third row, the least value is 6, 0, 2, 3 and 1. In fourth row, the least value is 5, 3, 0, 9 minus 5 is 4 and it is 3. In the last row, the least value is 4, 0, 2, 3 and 4. So now column reduction. In column reduction, the first column least value is 0. You will get the same value again, 2, 0, 3 and 0. In second column, the least value is 0, 3, 2, 0 and 2. Third column least value is 2, to 0, 1, 2 and 1. And in fourth column, least value is 0, it is 4. In fifth column, least value is 0 only. So this is your column reduction. So now we can go for row scanning and column scanning. In first row, I have 2, 0. You just skip that row. In second row, I have 1, 0. Put a vertical line. In third row, 1, 0. In fourth row, 1, 0. And in fifth row, no zeros. And in column scanning, in first column, no zeros. In third column, I have 1, 0. Put a horizontal line. Now you can cross verify whether it is satisfying the optimality condition or not. 1, 2, 3, 4. But it is not satisfying the optimality condition. Now, among these undeleted cell values, least value is 1. So today you learned one more important problem on traveling salesman method, right? So in my next session, I will discuss some other important and different problems on traveling salesman method. Thank you.